Section 20.1 Oxidation States and Oxidation Reduction Reactions. We've already looked at oxidation a little bit in Chapter 4, and you can go back and look at some of those lecture videos if you're still not sure. But most of the time, if you're thinking of oxidation, reduction, or redox reactions, there's some kind of a transfer of an electron, or at least there's a transfer of electron in terms of bookkeeping. Where's the electron at any one time, or where do we assign that electron at any one time? So you really assign numbers. It's not exactly does this atom or ion have a certain amount of electrons, but in a compound or in a formula unit, where do we place the electrons that's involved in the different relationships between the ions or the atoms or whatever. So you can think of it in general terms as how many electrons, valence electrons, does it have? Okay, so the oxidation number, when you keep track of it, it's a bookkeeping thing. We're going to assign oxidation numbers in order to keep track of where the electrons are. And normally an electron transfer is some kind of a redox reaction. Again, there's two major types of reactions in chemistry. You have acid-base reactions, which are transferring protons, and oxidation-reduction reactions, which are transferring electrons. So here's an example. If I take zinc metal and protons with that, the protons are going to seem to transfer onto the zinc, but what's actually happening is that electrons are transferring off of the zinc and going on to the hydrogen and making, instead of hydrogen aqueous, a hydrogen gas that comes out of the solution. The solid zinc then dissolves into the solution and becomes part of a solution. So when the solid zinc dissolves, that's called oxidation. And when something that's already in aqueous solution comes out as a solid, liquid, or gas, that's called reduction. So if you were to for instance, have metal that's in an ore, you can reduce that metal into its metal. So you can make aluminum, or you can make whatever, iron, or anything like that. So a species is oxidized when it loses electrons. If electrons go from one atom or ion to another, then a species is oxidized. So in this example, zinc is losing 2 electrons because it starts off as zinc metal with an oxidation number of 0 and turns out to be zinc 2+ with an oxidation number of 2+. It actually has lost 2 of its electrons, and so it is positive 2 as a resultant. A species is reduced when it gains electrons. So if something takes electrons from something else, it becomes more negative, and that's where the word reduce, I think, comes from. It reduces in charge. So for instance, if you have the hydrogen ion H+, and if each one of those hydrogens steal an electron, then that hydrogen is no longer a charged particle. It's now simply hydrogen gas, and it comes out of solution as bubbles. So this would be reduction. And what you're going to see is that in order for one species to be reduced, something else has to be oxidized, because where do you get those electrons? You get them by taking them from something else. So whatever gets oxidized is providing the electrons for whatever is getting reduced. If I take electrons from someone else, then I make them being oxidized. And I am the agent of their oxidation, so I am the oxidation agent. But if I'm stealing those electrons so that I can be more negative, then I am being reduced, and also I am the oxidizing agent. Conversely, if you are giving up your electrons, you become oxidized. But by giving up those electrons to another species, that species then becomes more reduced. So whatever's becoming oxidized is the reducing agent of whatever is taking its electrons.